have speed and torque. And between the two of those, that gives you power. Now, you can get higher speed but lower torque, but the power doesn't change. So you have, I made a little model right here. If I turn this one right here, see how that turns really fast? That has a lot of speed but really low torque. So it requires significantly more strength for me to rotate this than if I were to rotate it on this side. But this side, you probably can't stop that very easily because it has so much torque, but it moves so slow. But the interesting thing is that both sides have the same power. So whatever power you put into this side, you get out this side after you count friction. Okay? So that's a simple example. So you can calculate how much torque or mechanical advantage you will get based upon the teeth of each gear.
Hey, what are the teeth called?
No, teeth.
Togs.
Cogs.
Some people have not heard it as teeth. That's why, and some people have only heard it as teeth. That's why I wanted to say both. Because what if they'd only heard, cogs? So, okay, I'm done.
Okay. So, for example, you'll notice that you have the big gear. The big gear right here has 40 teeth. Each of your tables, you have a big gear. Okay?
So as a team, you guys are going to be building it together? Did you already build it? Oh, remember I said not to touch anything yet.
Alright, so the big gear has 40 teeth. Then you have these really tiny little gears. Each one has 8 teeth. So, that means you get 8 teeth to 40 teeth. So if you rotate the small one, how many times do you think the big one's going to rotate? Go ahead.
A fifth of its thing. If you rotate this one, you will rotate that fifth of all its teeth.
Yep.
Wow. That was good.
So it's a ratio of 5 to 1. 40 divided by 8 is 5. So if you rotate the big one time, how many times will the small one rotate?
5 times.
Simple enough.
Are you guys classical kids or something?
Alright, so that's a really basic thing. There's several different types of gears. You have the generic gear, or cog, for these. And then you have beveled gears, which I don't have any with me. But what they're actually designed to do is they're designed to be able to go at 90-degree angles to each other. And then you also have crown gears, which can only go at 90 degrees. So, so this is a crown gear. Go ahead and pass it around. You'll notice that it really can't mesh directly next to itself. It has to be at a 90-degree angle, and then it'll mesh really well.
Here's the one we have to see.
So you guys can...
Alright, so I think you all have the basic gears, which is the speed and torque. I'll explain the speed and torque, what that means a little bit more in detail real quick. When you have torque, that means you can move something over a longer distance, but because you can think of it as a ramp. When if you're pushing something up a ramp, and if it's really tight of an angle, it requires a lot of work really fast to get something up that ramp, right? If it's at a more shallow of an angle, it requires less work, but it takes longer, so it ends up being the same amount of work to get it over that ramp. That's how you can think of torque versus speed. With speed, it goes really fast, but it doesn't have a lot of strength. With torque, it goes really slow, but it has a lot of strength. So there's purposes for having both. Okay?
Bicycles.
Yeah, so like gears on a bicycle. When you have gears on a bicycle, you'll have, for example, first gear would be, I don't have a geared bicycles, but first gear would, for example, be when you pedal, when you have it in first gear, it'll require more work, but you'll go really fast. You'll go really fast, and you don't have to pedal a lot, but it requires some strength to pedal. But then you have second gear, it's meant for going up hills. You have to pedal a lot, but it's really easy to pedal. So it's easier for you to do it because it takes longer, but it's not as much of an exertion initially. Go ahead.
I actually have a bike in my car, in the car, that uses that. So if you put it on one, it's really easy to pedal, but it has not much torque. So if you're going up a hill, it's better.
Okay, so we're going to go ahead and do we're going to mess around with gears for a few minutes. So what we're going to do is we're going to try and just mess around with them. Let's try to make a little device that can translate the energy from, make it so it rotates 25 times to one rotation of what you rotate it one time and you'll rotate 25 times. So let's go ahead and try to do that, okay?
Okay, so FTP. You guys can get with me table.